Okay, hi Year 7. I'm going through the most average person task that you recently did. I'm going to go quite quickly, but you can at any point re-watch any sections that you need to, or pause and take your time. I would recommend having this available. It's a bit difficult for you to see here, so have the work that you did available for you to watch. And let's get going. So Mr. Blackshaw is preparing to give a presentation to Year 6 parents on what the average Year 7 KG5 student is like and needs your help. He's already collected data from a sample of 15 current Year 7 students. So you've got that data here as well that was provided. Your task is to help represent and analyse his data by creating tables, charts and graphs and calculating averages. You can use a calculator and you may also need some geometrical equipment. So first part then. Mr. Blackshaw decides to look at the students' houses first and asks you to complete a frequency table in order to find the average house. So we're looking at this data here, the different houses. So we've got Upstill, Rowell, Crozier and Nightingale. That's what those letters stand for, but if you didn't know that, it's fine, you could just put the letter. So this data is, it's not numbers, okay? It's categorical data, it's a category. Okay, remember we've got two types of data, numerical and categorical. Numerical is a number, so this one, and this one, these are all numerical. And then the first two, male and female, and the last one, school, are categorical as well. Okay, this is going to impact the type of average that we can calculate because so I've just misspelled that, let's write that again, numerical, because we've got three types of averages. Okay, so I'm going to be writing just a few notes around here as some reminders as well. We've got mean, where we add all the numbers up and divide by however many there are. So that needs to be numerical to add them up. We've got median, where we put the data in order and then look at the middle one. So again, we can only put data in order if it's numbers. And then we've got mode, and mode is just the most common answer. All right, and we can use mode for both categorical and numerical data. Okay, just looking at the one that's the most. So first of all, let's do our tally. And I'm going to go through and cross off these as we go. So I've got one Upstill, I've got a Rowell, Crozier, Upstill, Rowell, Upstill, Nightingale, Crozier, Upstill, Nightingale, Crozier, Nightingale. All right, there's my tally, and I've crossed all of those off as I've gone. So I just add those up to get my frequency. So it's 4, 3, 2, and 6. Which is the most common? Well, the most common one is the one I've got most of, so that's Upstill. So you could put a U there, or you could write Upstill. And what is the name of this type of average? Well, we've got three types of average to choose from. Mean, median, or mode. Well, it's the most common, this is the mode. And why is it best to use in this situation? It's not just the best, it's the only one we can use in this situation. It's the only average we can calculate or we can find when we have categorical data. Okay, it's not just the best, it's just it's not possible to find the mean or the median of a house. All right, moving on. He next wants information on the number of siblings. So the fact that it says number of siblings, we're now going to have numerical data. And where is this one to be found? It's here. So now we have to put our focus on this bit of data. He asks you to create a bar chart and find the average. So it says average. When Mr. Blackshaw's saying average, you're going to get to choose if you do mean, median, or mode again. And this is part of the real life application that you're making a choice and then saying why you made that choice. Okay, let's create a bar chart first of all. So I'm going to look at my data, it's here, and I'm I want to know, okay, well, how many people had 0 siblings? I'm actually going to start by doing my own little table. I'm going to use the numbers across here, and then I want to know, so this is my number of siblings, and I want to know what was the frequency. So in the same way, I'm adding up how many I've got. This table here was horizontal. This one I'm writing vertically, but it's exactly the same. I'm just doing it because it kind of matches with those numbers that are already drawn on the bar chart. So I've got one person who's got no siblings. Now I'm going to look for ones. 1, 2, 3, 4, 5. Twos, 1, 2, 3, just 3 of those. 3 siblings, 1 person there and 1 person there. 4 siblings, just that 1. 5 siblings, those 2. 6 siblings, nobody's got 6 siblings, and 7 siblings, that 1 person there. So I do think it's a good idea to draw on this as you go to help you keep track of what you have and what you haven't counted. And now I need to transfer this onto my graph. So this is discrete data. It means you go from 0 to 1 to 2. You can't have anything in between. Okay, it's what I call frog data, jumps from one to the next, not snake data, slides from one to the next, not continuous. So just a reminder on that. When we have discrete data, we have gaps between our bars to show that there is a gap between that data. Okay, you are going to use a ruler to do this. I'm going to do it by hand just to save a bit of time. Actually, I'm going to pause and draw that out. Okay, so that's done. And I just use a kind of mathematical way of shading. We don't need to do it. It looks like art, but as long as each of our bars, we've got the same width on each one, they go up to the right height. Okay, now I'm going to think about which average I'm going to use. Well, the easiest one to do is probably just the mode. How many siblings do most people have? And I can find that just by looking at the bar that's the highest. Most people have 1 sibling. Okay, so that's a perfectly good average to use. Most people have 1 sibling. And when I say most people, I mean out of the 15 people that were surveyed in the experiment. Okay, there is another way we can calculate the averages though. We could look at the mean or the median. And I think it's probably easiest to go back to our original data to find the mean or the median. So remember, for the mean, we'd add them all up. So it's the sum of all our data values divided by the number of data values. Okay, so here, I know that the number I've got is 15 because I'm given a sample of 15. I know that's going to be 15. To add them up, it's easiest to go from my raw data. I'm using this calculator, but it's going to work the same as your calculators. I'm just going to add these up. So 2 plus 1 plus 1 plus 5 plus 1 plus 2 plus 2 plus 5 plus 3 plus 4 plus 7 plus 1 plus 3 plus 1 plus 0. I don't need to put plus 0, but because it doesn't make a difference. Then divided by 15, I get 2.53333333, which we can write as 2.53 if we round it maybe to 2 decimal places. Okay, so even though you might be thinking, hang on a minute, I can't have 2.53 siblings, that doesn't make sense. You're right, it doesn't really make sense, but we are allowed to calculate the mean and say that's the mean number of siblings. So it would be a valid answer to say that the mean is 2.53 if Mr. Blackshaw asked you what the average was. Okay, and the other average that you could have chosen was the median. So how do we find the median? We write out our data in order and then we find the middle value. Now I think it's probably easiest to write out my data in order using these frequencies. So I've got 1 0, I've got 5 1s, I've got 3 2s, I've got 2 3s, 1 4, 2 5s, and a 7. So I've got 15 data points there. Which one's going to be in the middle? It's going to be, I can either cross it in from both sides, or I could say, another way of finding it is you add 1 to however many you've got and then divide your answer. So it'd be the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so sorry, I said divide your answer, but divide your answer by 2. So the 8th value is the median, or like I said, you could just find it by kind of crossing from both sides until you get to one in the middle. So my median is 2. And that would also be a valid answer if Mr. Blackshaw asked me what the average number of siblings is. Now, I've gone through all 3 of those, but you only needed to do 1, and whichever one you chose, you were then asked to say which average did you use and why. Does your answer make sense? Okay, and this is just getting you to think about, okay, is my answer reasonable? If you'd got an answer like 10, you might be thinking, well, how can the average number of siblings be 10 if nobody has even more than 7 siblings? Okay, so whatever reason you put is fine. So if you put mode, I found the mode, does my answer make sense? Yes, because most people have got 1 sibling. If we found the mean, yes, my answer makes sense because it's in the middle of the data set. So both 2.53 and 2 is somewhere in the middle between 0 and 7. It's not outside of that range. As long as you put something sensible there, you'll be all right. Okay, moving on. Next, we want to show the proportion of students from each primary school. So now the data that we're looking at is this one. Okay, again, it's our categorical data here, and you're asked to design a presentation. What type of chart is best for showing proportion? Now, pie chart is really the answer we're looking for here because we get a nice circle and it's divided up into sections. But you could also say that a bar chart would be a good one as well. Anything visual that shows different areas that we can compare. But ideally, we'd use a pie chart to show proportion. So how are we going to draw a pie chart to show proportion? Well, we need to know what the angles are. So first of all, I need to take a look at my data and look at the different schools that Year 7 students came from and how many we had from each. Then I'll start thinking about, well, what angle would be an angle that's representative for that. So I'm looking at my data. I can see I've got some students from Beacon Hill School, some from SJS, some from KJS, and some from Clearwater Bay. So I'm going to add up the numbers from each. So Beacon Hill, I've got 1, 2, just 2. SJS, 1, 2, 2 again. KJS, 1, 2, 3, 4, 5, 6. Clearwater Bay, 1, 2, 3. And there's still, oh, and I missed one here. Okay, that's good. It's good to cross them off as we go. So if we miss one, right, so actually that should be 4. And then there's an other, which is just 1. And a nice way to check I've got everything is to add these up. I know that I've got 15 students in my sample. 2 plus 2 plus 6 plus 4 plus 5, sorry, plus 1 is 15. So I know I've got them all. Okay. So one way to think about this is as fractions, and then we'll turn that into an angle. So as a fraction, 2 out of 15 students went to Beacon Hill. So I want 2/15 of my pie chart to represent Beacon Hill. Same here, I want 2/15, 6/15, 4/15, and 1/15. Now, 2/15 of what? 2/15 of my whole pie chart, which is 360 degrees all the way round. So now I'm going to work out the angle that I need to draw for each school. So I want 2/15 of 360. So this angle will be 48 degrees. SJS is the same, so it's going to have the same angle. Clearwater Bay, I'm just jumping over that one there, is actually double, right? So I'm expecting my answer to be double 48. So I can either just do that times 2 to get 96, or I could say 4/15 times 360 gives me 96 degrees as well. Same for 6, I could say it's 3 lots of 48, or I could say it's 6/15 of 360. And the last one is 1/15 of 360, which is 24. Again, I want to make sure that these angles all add up to 360 degrees. Sometimes if we need to round our numbers, it might not add up to exactly 360. But here I didn't need to round anything, so it should. Now I need to get drawing. So I'll just grab my equipment. Okay, I've got my compass and my protractor. I'm going to use a compass to draw a nice circle. Now you can draw a circle using other things, so I could have used a cup or anything circular, but the advantage of using a compass is that you get a little dot where the center is, and it's really helpful to know where the center is. Now I've made mine a little bit too big there, but never mind. I'm looking at where that dot is from the center, and I'm going to mark that on there because I do need to know that. When I drew my circle there, I held my compass by this bit, and I like to turn the paper rather than turn the compass. I think it's easier. I'm also going to use a pencil for this in case I make a mistake. I think I just need to use the pencil from my compass. So I need a starting point. I need a starting point of a straight line from the center to the edge. And now I'm going to get going. So first angle I want to measure is 48 degrees. I'll put the cross over, exactly over there, the 0 line along there, and I'll read around from 0, 10, 20, 30, 40, 8. A little dot here. Now it's outside my circle, but that's okay. I use the straight edge to go line up my dot and my center, and I go from the center until I hit the edge of the circle. Okay, this I'm going to label 48 degrees, and I'm also going to label it BHS. Okay, then I'm going to turn my paper. I'm going to do it again. Now I use that line as my starting point. 0, 10, 20, 30, 40. My dot is out here. So I line up that dot and the center. But I don't go all the way until I hit the dot, just go to the edge of the circle. I've got another 48 degrees SJS. Okay, you can fast forward through this part if you want. I'm going to go around and measure all the angles. The next angle is 144, so it's going to be more than 90. It's going to go all the way around. 90, 100, 110, 140, 144 is there. So from the center through to that dot. This angle is 144 degrees and it's KJS. Next one is Clearwater Bay, 96 is the angle. So there's 90 and another 6. And what's left should be my remaining 24 degrees, but I will measure it just to make sure. Sometimes it doesn't work out perfectly because I might have gone plus or minus half a degree as I go around, but I'm just going to check it's close enough. Okay, so there, 10, 20, yeah, that looks good. Okay, so I'm going to label that one 24 degrees, and this section is other. Now we could colour that in, and to make it look even better, I've just done some basic shading there to save a bit of time. What does your diagram show about the proportions of students from each primary school? So here, we're basically just looking and trying to get a few facts that we can get from this pie chart, or you can even get it from the data itself. So there can be lots of different possible answers here. You could say it shows there's the same proportion of students from SJS and BHS. We could say that most of our students come from KJS. We could say that over a quarter of the students have come from Clearwater Bay School. We could say that there's the same number from Clearwater Bay School as there are from SJS and BHS combined. Here could really have just been anything that you can see from looking at your chart. Okay. Next part. In the whole year, if the whole year group has 300 students, how many do you think are from CWBS? So we've already said that we had 4 out of 15, so 4/15ths of our sample. So a sensible guess would say, okay, if we've got 4/15ths of our sample from CWBS, then maybe 4/15ths of all the students are from CWBS. So what's 4/15ths of 300? Again, I use my calculator. You can do this in a different way. You can do 4 divided by 15 times 300. You could do 300 divided by 15 to find 1/15th, and then say, okay, I want 4 of those. Either way, we get an answer of 80. So 80 would be a really sensible answer here. Oops, I should have written that down here. I've written that in the wrong place, never mind. How many do we think? Well, I would guess 80 because of that reason. And then, is this answer exact? Lots of people said here, yes, it's exact because it's a whole number and I used my calculator. But what this question is really digging into is, just because I'm calculating 80, does that mean there will be exactly 80 students from Clearwater Bay School? And the answer is not necessarily. And what we're trying to dig into here is understanding that a sample of students doesn't always have the same proportions as the whole population. Let me get my spelling right. Not necessarily. Okay, so why or why not? Because the sample is just 15 students and might not have the same proportion as the whole year group. Now, you don't have to put it in those exact words, but words that reflect the same idea, understanding that within a sample we can make estimates and we can say what's shown within that sample, but when we scale it up to the whole population, and the population here is the year group, it's not always going to be the same. Okay, last part then is Mr. Blackshaw decides to investigate if there's a relationship between students' shoe size and left hand span and asks you to carry this out. Now, this is really only applicable as a kind of extension part for those people who either have learnt before or who got onto doing scatter diagrams. So when we're looking for a relationship between two numerical values, and here the shoe size is given in a number and the handspan is given as a number as well. When we're looking for a relationship, we do something called a scatter graph. And this is a little bit like doing coordinates and then looking for a pattern in the coordinates. So we've put the two things on axes, put one on the x-axis, so shoe size for example, and one on the y-axis, and then we're going to put that data onto there. Now I'm going to use a previous answer that's here because it includes nice squared paper so we can see it easily. We can see along the bottom we've got left hand span. Now there's no one with less than 12, so what we put in here is a little broken scale because we should start at 0 really. It goes along, and then a broken scale here because we're starting from 34, And each cross that you can see on here represents one person from our data. So let's have a look here. We're looking at shoe size and handspan. So this person has a shoe size of 38 and a handspan of 16. So if I was putting that on, I'd look up here to get the shoe size of 38, handspan of 16. So that cross, which is already there, represents the first person. The next person is 39, 15. So that would be here, because it's 15 there and it's 39 across. So when you put all of those on, we get 15 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then I think here we've got 2 people, which is why it looks kind of double. So this would be 37, 17. And if we look on here, we can see we've got 37. Oh no, sorry, 37, 17 is that new person who comes in that we talked about next. So on here, it's that new person. So some of these other crosses, maybe if they're doubles, I'm just going to look on this data for a double to explain what I mean. So for example, here we've got 2 people, both with a shoe size of 39 and a handspan of 16. So 39 and 16. I've already got a cross there, so it's quite hard to do a second cross. You can sometimes do a kind of second one over the top, but that's why it looks like there's just 13 crosses there. So this is what your scatter graph would look like when you put all the data on. I hope this is the same data that we used, but the idea is the same, that you end up with a scatter graph, and it shows, I'm just going to do just a sketch of it here, I'm not going to go into that a lot. It shows a positive correlation. Okay, positive because it looks like as one gets bigger, so does the other one, between those 2 things. And a new student comes in with a shoe size of 37, a left hand span. How well does it fit in? We put them on there and we go, okay, it fits quite well. The last part is just asking, sorry, I've skipped over that because not many people have done that one. And then to finish, can you summarize your finding and describe the most average person? So we're going to go back to the beginning and we're going to look at all the data, all the things that we found so far and try to give the most average. So we know that their house is in Upstill. That was from our first question. We also said that their number of siblings, and it depends which one you chose, but maybe we're going to say number of siblings is, I'm going to say 2.53. I'll use the mean on that one. Their primary school is Clearwater Bay School because most people went to that, and the mode is the only choice we have for categorical data. Maybe we'd have a look and say it's somebody with a handspan of 17 and a shoe size of 37. You could pick some different numbers, probably there would be okay. And then you could also go on to even have a look at some of the data that was provided for us, but we haven't looked at yet. So male and female, does it even make sense to say that an average student is male or female? Well, we've got slightly more females in our sample. We've got 8 females and we've got 7 males. So would we say the average student in year 7 is female? Or would we just say actually it's about half and half? We wouldn't comment on that one. You could also look at height. We haven't looked at that data yet that was given to us. So again, you could calculate the mean, median or mode of the height. I'd probably suggest using the mean or the median there because we've got numerical data. So there's quite a lot of scope to get very detailed in this last part, depending on how much time you had. And I'm going to stop there.